And as always, my camera is off. Okay. Finally, I'm on time. Hey guys, do you have chat enabled here? Can you type something? Hey Steve. Finally, I got it to work. I came here, I came to prepare about 2 hours ago, and apparently YouTube won't let me do it from my iPhone, which is what I normally do. And I had to do some sorcery over here with my webcam and installing some applications. Hopefully you guys can hear me now, at least. I would like to wait a little bit because it's just, I believe it's 5 people right now, if you guys don't mind. I'm late with the hot end, but I'm on time with my video. Or should I just start and not wait for people who are late? I'm actually expecting questions from you guys. And if you have any questions about add-ons, how is the sound? Can you hear me? Guys, there is a chat supposed to be somewhere on your right, which I'm expecting you to use. Okay, sounds good, finally. Thanks God. I was actually trying to check it, and it's really hard to check. Anyway, so today I want to cover mostly for the add-ons, and I had a lot of questions on Kickstarter about add-ons, what people should use. Hi, Joan, or Juan. I'm sorry if I butcher your name. In Russia, we read it straight. Hey, L3D. So basically, I expect questions from you guys today. If you want to ask some questions about add-ons, or you ask some random questions about whatever you have on your mind, especially bakers who purchase the product. I could start from just showing some final production. These things came out so shiny, as you see. They came out so shiny, so I didn't even put them all over here because they kind of attract fingerprints. They came out too shiny, I'd say. And I want to show you guys. This is a heat block, and here's how it looks. How it came out, pretty nice. That's another heat block, and I'm gonna put fingerprints all over it, probably. But that's how it looks. And the sensor goes vertically, and the end of the sensor is supposed to be aligned at the bottom. And let's get some nozzle, for example, random nozzle from my rack. So basically, nozzle goes in here. My camera is set up not in the best way, I think. Let me move it a little bit. Just a bit closer. I even don't mind if my head is not going to be visible, because I don't think it's the most important part. So even if it's a little bit, cut off, I think it's still better. So I can at least show the actual product. Hi, Mark. Okay. So basically, as you see, when you insert the nozzle, the most important temperature part is at the bottom of the nozzle. So what I did, I made 15mm long thermistors, not thermistors. I have let's call it thermal sensors. And the actual sensor is not all the way. The actual sensor is at the bottom. So what's going to happen? The sensor is going to be located right in the right spot. where you want to read the temperature of the plastic first. So sensors I'm going to insert from there, and you go into, there will be a little set scroll over here, which to tighten the sensor. It's not located exactly in front of the sensor. There is a reason for it as well. I don't want to squish the sensor, so you kind of push it from the side. There is a hole as well over here. I will try, of course, to cover all that in my manual, but for those of you who just wondering, right? So there is a hole in the middle over here, which is supposed to help you to actually change nozzles. And if I find my, oh, maybe I don't. Okay, guys, excuse me for a second. I forgot heat brakes. Heat brakes are somewhere around here. All right, heat brakes. So basically, that's a heat brake, and if you're lucky, you may be able to see it. The heat brakes goes from the top, similar to how E3D is doing it, which I'm not a fan of, but I couldn't find at this point. I couldn't find any better way. So basically, when this all is attached like that, right? This is how when you change nozzle. And when you guys change nozzle, you probably experience this a lot of times. So this is going to rotate together with everything. It's just so inconvenient. So basically, this hole in the middle between the screws over here, it's actually intended for you to actually hold the block. The hole is exactly 2 millimeters, so you can insert any kind of like thin screwdriver in here. And this way, you actually hold the block while you can tighten this. And speaking of tightening, here is the nozzle tool. I actually machined a very special nozzle tool. How about I actually zoom in onto my table and just remove my face completely? What do you guys think? Yeah, let's look into that. I don't think my face is at all important over here. So I'm just gonna do it. I wanna go much closer, actually. Maybe I'll even stay on this side. How about this? Looking good. And yeah, let me stay on the back. You have already seen me so many times, pretty much. So let me stay here on the back, and I'm just gonna use my laptop over here. All right, how is this, guys? Looking good? Okay, great. So basically, what I was showing you this thing. It's gonna be much better now. So this is the heat block I managed to produce. It looks amazing. It's like it's more back up like. Okay. Anyways, heat block looks like that. And what I was telling you, once it's not tightened, it just goes all over the place. And for now, I'm still not. I haven't still figured out how to make it better than this, which I will, by the way. But at this point, this is the design, and I'm gonna keep working on it. So this is the hole I was showing you, and this hole is exactly intended to hold it. It's really easy. You just insert the screwdriver, like any hex 2 millimeter screwdriver. You insert it all the way, and then you hold it. Same happens when you want to tighten your heater cartridge, or you want to tighten your anything pretty much. So for the quick swap, I want to cover quick swap as well. Quick swap is for the rich kids. That's how they call it. So basically, if you want to change, here is the heatsink, right? So if you guys want to change, instead of the nozzle, if you want to change it fast, or maybe you don't want to mix colors and stuff. So if you don't want to mix colors, or you just want to like really convenient and quick change. So basically, this is what you do. Tolerance, by the way, tolerance is just over here. There's no movement. Like if I don't angle it right, it won't even go. tolerances came out so amazing. So anyways, if you guys want to change it, so that's how it's gonna print, right? Like that. So we can go a little bit closer. Okay. Okay, this is right. Okay, it's gonna print like that. So if you guys want, and the way you attach it is with the set screw over here. There's a little set screw. I don't know if you're able to see it. There is a hole. I don't have set screw with me now, but basically, yeah, that's how it holds. And if you want to swap like the core you just lose it. You just make it a little bit. You just relax this knot over here. You know, pull it out and insert the next one. Fix the nut, and you're done pretty much. This of course involves, you know, extra. You're gonna have extra sensor, extra this and that, but it's really convenient. Not cheap, but it's really convenient. I want to cover how it actually works. What's your plan with people making their own mounts for the Nova? Because I'm sure plan on making one. Yeah, audio is pretty horrible, guys. It's because that's all I got. And it's really horrible just because YouTube won't let me do it my normal way. And normally I do it from my iPhone, everything. And YouTube basically didn't allow, because I didn't have 1,000 subscribers, and it won't let me do the normal way. So unfortunately, that's all I got. Audio is gonna be horrible. I'm sorry, guys. So what can I do? Anyways, for the plan for mouse, I'm going to release probably within 2 weeks. You guys going to get drawings. I'm not going to release full drawings until it actually finally ships, but you're going to get drawings for the Nova if you want to do mounts. So, or if you have any like questions right now, you can basically, you need a length. You know, length is 45 millimeter from head to toe, like that. This is 45 millimeters over here. These holes are M3 over here, and they're located 17 millimeters apart from each other. Basically, that's pretty much all you need to do a mount. The diameter over here is 22 millimeters. I did it the same way with E3D, just because originally I thought maybe it's going to be easier to make a fan mount, but it's not. So I ended up doing my own fan mounts. This is the set. This is how it's going to come, and basically. You know, I was trying to do some foam inserts, you know, all that kind of stuff. It's going to have box, of course, but in the end, I decided just to 3D print this, and it's like it 3D prints like that, and then I just, you know, wrap it sort of like this, and I'm gonna insert it in the package. So basically, this is kind of a pro package. It's a full package. So as you see here, I don't have sensors yet in stock. That's why you don't see it here, but sensor is going to be included as well. So, guys, I'm going to cover your chat. I'm trying to finish with this thing first. So this is how it looks like. This is how it's going to come. Nozzles. This is additional nozzle, right? 6 additional nozzles here. Included nozzles is going to come here. Over here, you're going to be able. Why I made 6? Because people not going to take more than 6 nozzles probably, and 3. I have 3 sizes. So 3 sizes for hardened steel, 3 sizes for brass. And even one more over here. So, okay. Yeah, I've actually moved my microphone a little bit, but it's not even a microphone. It's like my weird webcam. I actually have a good microphone, which I wasn't able to not able to work out completely right now, just because of this surprise with YouTube not letting me use my iPhone, and that microphone is supposed to work with my iPhone. So unfortunately, yeah. So basically, yeah, guys, I wanted to make it also not boring, because a lot of like stuff for 3D printing on the market is like really boring, and I don't like boring stuff, you know. Like, why not make stuff, you know, a little bit exciting, right? So this is the fan, and the fan mount is going to be 3D printed. I was actually choosing the materials for quite a long time for this kind of. You see, this is it's printed with carbon fiber PLA, but it's actually annealed after printed. So once you anneal it, I think that's the best choice pretty much, because basically, I tried ABS. ABS is kind of hard to print, and it's gonna look a little bit worse, and it's gonna shrink, and it's like there is a lot of problems. I tried nylon. Nylon is too flexible. I tried a lot of stuff. PEEK obviously too expensive. So basically, yeah, this is the fan I chose. It's 25mm fan with 9 blades, and it's going. You're gonna be able to choose 12 volt and 24 volt. I mostly purchased 12 volts. I think I have like 212 volt fan or 300, and then I have half of that of 24, just because you can actually put 12 volt fan on any system and just run it at half of speed, because boards are usually control fans with voltage. So yeah, let's see. What did I say? I don't have any water-cooled blocks yet. I'm actually in the process of developing Supernova, which is supposed to be sort of similar to DICE Typhoon and to E3D Super Volcano, but different. I totally took different approach. I didn't add height. I didn't add lengths. I took it absolutely differently. I'm not sure if it's gonna work. I still haven't seen the prototype yet, but yeah, I took a different approach. If you about water-cooled blocks, I covered. So for Nova, I will have water-cooled blocks, but guys, you really don't need water-cooled blocks for Nova. Like it was kind of original plan to have water cooling, but to be honest, like I can cut the size of this twice, even like twice shorter. It's just gonna be fine. As you guys seen, I was printing without fan for like a month. there was like zero fan over here. I mean, of course, you have to consider it, like you can just leave it idling for like half an hour at high temperature, but you don't need water cooling. I mean, like it's kind of, I think the problem was why people started water cooling with the 3D design, because of the threading. They had a lot of air. They had a lot of like, it was pretty loose. And maybe that's why. That's my guess. I'm not sure why, but maybe that's why. Basically, on this design, you don't have that. And even if you like do have some sort of temperature, I'm gonna include a big, pretty good amount of thermal paste, just in case you want to use it. Just because why not? And the next one is gonna be. Yeah, guys, I am gonna need some reseller in Europe. Probably. I spoke to 3D Print Man, who is my buddy. We speak a lot with him. He's a really nice guy, and he actually offered me to maybe ship European orders to him, and he could just forward it. But I'm kind of seeing how I can not overpay, because basically I'm just gonna be negative on this shipping cost probably. But it was fun anyways. Thank you guys. Thank you guys. Thank you a lot for your support, for your comments. I have been a little stressed for the last week and a half probably, just because it's been like plenty of like issues with production, and it's really hard to set it up ideally. And I'm trying to be like, I'm perfectionist by heart, so I don't like, if something is wrong, I don't like it. So for example, this is still imperfect. I'm gonna ship it because you guys gonna say it's fine, but like I want it polished a little bit more over here, and these sleeves are a little bit too loose to my liking. Basically, manufacturers, they hate me. They probably hate me. They kind of block me probably from the next order. So over here, that's actually. Let me go to actually these heaters. Also, just look at this horrible. Like I'm pretty bad at sales, so I'm gonna show you right away. Look at this horrible engraving. Like we have to deal with this for the first order, but that's just horrible. I don't know how they messed up engraving so bad. So everything else is fine. Everything else, I check functionality and everything, and I just don't have time to redo it third time. It was already redone. First time they actually made their own metal. A lot of stuff was stressing me out, to be honest. So that's why I kind of reacted a little bit on Kickstarter as well. I really apologize for that. Yeah, hopefully 2 weeks, because sensors are in production. So the reason sensors are actually delayed is just because this company was actually supposed to produce sensors, and I dropped them in the last when they made the first mistake on heaters. I actually dropped them and I started searching for a new supplier for sensors, because I've been working with China for like over 7 years, and if something is like not right, I have a gut feeling, and I don't want to like continue working with the company, because it's just going to be a nightmare every time. I don't have imperfect variants. If I have them, I actually force the factory to remake it because I'm so bad. So I'm so bad customer for them, I guess. So what I want to show you guys, if you can afford it, like I really try to keep prices as low as possible. And even for now, I think this is a hell of a deal. You know, to get it even for $100 is like hell of a deal. Like, it's in my opinion, because I know how this stuff, like how it's made, and compared to whatever is on the market and how that is made, I think it's really good deal still. So if you have a budget, I really suggest this tool. This is a nozzle tool. I made it. I custom designed it, of course, because it's fun to do custom design. So it has a little hole just in case you want to use it like a wrench, like that, and it inserts in any normal hex socket on any standard screwdriver. And over here you have a nozzle shape. It's very low. It's very tight tolerance, so you don't really scratch corners of a nozzle, because it just really is pretty tight. So basically, you just it's much easier to install nozzle this way. So you will have to tighten it, but you need to make sure you don't over tighten it. It doesn't require to be really tight. And something one of my customers actually was buying titanium heat brakes for V6 from me, and he actually pointed out something to me which is interesting, which I want to mention right now, and then I'm gonna go to chat. So he said, like, they have a lot of he had a lot of clogs because of like a little chamfer in the end of on this end on the V6. They had like a little chamfer there, and apparently when plastic solidifies, it actually causes a blob, and that's what clogs the hot end. Maybe that's why I was not able to clog Nova. And even when Nova, I was actually, to be honest, I was able to clog it once because I forgot it on 240 degrees Celsius. There was PLA inside, and I forgot it without fan for half an hour, and that's how I got it clogged. And it was, to be honest, I cannot call it clogged, because all I had to do, I had to dismount the core and just pull the plastic from here. There was nothing like holding it inside, basically. So what I wanted to cover here is the way I made the connection over here. This is a conical connection, so basically it inserts into one another like that. And this is how you don't really have any chamfers, any blocks, because over here you have like a column, right? And here you have a reverse column. So basically, yeah, you just connect it like that. So that's what I wanted to show you, why I think it might Nova, like, it's so hard to clog it, nearly impossible. Maybe that's why. To be honest, I don't know why, because I was just doing it from the scratch, and like, I don't know how to make it not work, because basically I just made it this way, and I was thinking about every little detail while designing the whole geometry. Store orders, actually, I have about 50. I sold about 10 Novas on top. So about 40 Novas I still have free, and you guys can buy it. It's not going to be it's not going to be Kickstarter price. Right now it's 124. It might go to 150. I'm not sure. I don't want to go to. I don't want to like raise the price too much. If I get decent volume, I'm not going to raise the price further. So it's going to be like 125 for the hot end, and you guys can buy it if you need extra. For the Kickstarter backers, I can keep the price. If you just contact me, I can keep the $100 deal if you like want to buy an extra Nova, for example. And speaking of all the add-ons, they're gonna be available on the shop, on the 3D Passion store. on 3dquestion.com website, and basically I will order the price. If you guys, for example, did not get all the add-ons you want, you're gonna still get the same Kickstarter price if you want to do it later. So what else? Oh, what else? Something interesting. Meanwhile, I want to cover. Let me read the chat. If you guys have any questions there, or maybe you don't. Yes, gold-plated connectors. Actually, I didn't mention it. One guy actually asked me on Kickstarter the question about like what kind of connectors do we have to buy for the second side of this? And I was like thinking, how is the industry treating you guys? Like, why do you have to pay for the product and then have to deal with buying connectors? Of course, I mean, of course, I included the second part. So this is EC2. E is in Edward, C is in Charlie, and then number 2. The connector is called EC2 connector, and it's gold-plated. And I am including. Okay, I lost the video just now. Okay, that's Wi-Fi camera, so it's not very reliable. But it was 20 bucks. So these are the connectors, EC2. I think I use it for RC batteries, and I think they're super reliable. You can run a lot of current through this kind of connector, even if it's tiny. So basically, you guys are gonna have it here. It will require soldering. I hope you're okay with that. And the fan, actually, this fan is not the fan I'm produced. I haven't gotten a fans. And what happened? The reason for my partially the reason for my stress was because fan got lost in the transit. So I was supposed to receive fans last Monday, and they shipped it to Hong Kong, and they got lost. Basically, the package got lost, and there was not only fans, there were some special screws, because I was using soft tip screws for the heatsink, so you don't scratch the titanium heat break over here, because that came to me kind of afterwards, and I decided, why don't I use something nicer? So fans are going to come with this kind of connector on one side, just not two, it's gonna be just one together. This kind of connector, and you guys going to have a female part for it with a little bit of wire. So I decided I could just provide these things to you, right, with the plugs, but they require crimping, and not everybody has crimping tool. So basically, what I provided the whole piece over here. I gave you the fan is gonna ship with this thing, with female connector and a little wire, so you basically can just solder it, or even cold solder if you don't have soldering iron. I think it's much easier. Reading the chat, I give you 1 second, guys. I don't want to skip anyone. Guys, shoot me your questions, because that's what I'm here for. Shoot me your questions. If you have questions about add-ons, about anything, ask me. Also, I'm kind of thinking of extruder, of making the whole thing, right? And what's interesting, moons. Have you guys heard of these motors? They're supposed to be a high quality, upscale, or whatever you call it, steppers for extruder. And I will talk about them in just a little bit. So let me cover. I want to cover nozzles. And 11 people are not gonna break this thing, just because I'm gonna tell you how to unplug the nozzle. So the way I 3D model this set, there is just a little piece of threading on the bottom, so you have to actually unscrew the nozzle, and you have to rotate it a little bit, and that's how you unscrew the nozzle from the set. There is a threading on the bottom, not all the way, just on the bottom, because I was trying to optimize the actual printing, because obviously I have to print 200 of them right now, and who knows how many later. So the nozzles, as I promised you guys, by the way, the nozzles are going to be polished. They are already polished, by the way. They're not going to be polished. So I'm gonna have to refinish them a little bit, because my manufacturer shipped them instead of individual packaging. like this, or like in some kind of foam, they just put it in the same bag. So basically, they were polished originally, but they got a little bit. Let me see if I can get the focus on it. Can you see my reflection in this nozzle? That's 3D pressure nozzles, and I think that's how it should be coming. It's not just for the appearance. While they look beautiful, of course, when they polished, it's actually helps a lot with the plastic, not with sort of non-stick properties. Even if it's brass, even if it's not covered with any kind of nickel plating or chrome plating, it still helps a lot when it's actually polished. And if you guys can polish your nozzles, try that at home as well, and it actually helps a lot. And not just that, what also helps is the shape of a nozzle. As you see, my nozzle is it concave or whatever the curve is in there. So you kind of don't have a lot of hot metal, you know, ready to take out your plastic. You only like have a pretty sticky, pretty pointy nozzle in the end. So that's what helps. I was thinking, you guys may ask me, it might actually reduce the temperature in the end. It actually doesn't. I don't know why. I actually tested it, and it doesn't really reduce the temperature, this kind of shape. I was worrying about it as well, but no, it's just printing just fine. Okay, let's cover adapters right now. Here, the first adapter is M12. Some of the guys from Kickstarter, they actually asked me, some of the bakers, to produce, and I said, you know, yeah, let's produce it, why not? And basically, that connects. I'm trying to make like Nova as universal as possible, so you can. The best way to connect it is using these two screws, in my opinion. That's why I designed it this way. But if you have, for example, smart effector kind of print head, you can, and smart effector is designed for this sort of mount. So basically, you have this. And my bolts was also lost in the last package, so they're gonna come in a bit. So you're gonna have a nut over here, which was lost. Nuts were lost, and I messed up a little bit, and I totally forgot to give you something here to actually tighten it. But basically, yeah, that's my bad. I think it's not a huge deal. It's still, you can still tighten it pretty well. So it still works. Next time I do a little improvement, but it's still very, very decent right now. Yeah, Ilya, I'm actually, that's what I'm explaining right now. This is the adapters. So first mount, especially if we are repeating right now, first mount is this, number one. This is Nova kind of mount, so you don't. Then you have number two, option number two, to use this kind of adapter with a nut. Nut is going to be provided as well. And we are going to number three right now. And number three is right there. Why don't just make it red, you know? I don't understand other manufacturers. It's not that expensive. Like, guys, don't be so cheap, okay? Don't just make ugly stuff. It's not that expensive to make it red. So, and I think it looks pretty nice. So over here, I didn't mess up. So over here, you can actually tighten it right here. As you can see, over here, you can tighten it with a wrench. But you don't really need, I mean, if you do it like that, so it's already pretty strong. So this is a groove mount adapter. I do not suggest anyone to actually, if you can, try to get rid of this mount. It's actually very flawed mount, just because, you know, this part that holds it over here usually wears off, and then you're gonna get wobble. And even if it doesn't wear off, it's usually plastic, and you still get wobble. And like attaching something like that, in my opinion, just not the best, not a good idea at all, because it has to be really, really sturdy over here. And yes, I made it shorter, which is gonna help. It's gonna look like that with an adapter, but it's still, if you squeeze it like that, it's basically like writing with a pen, holding it at the top. You're just gonna get a lot of wobble, and you might experience printing issues from that alone, in my opinion. So basically, yeah, I do not recommend. But if you have a printer that is already set up and you wanna have it for an ease for now, that's your solution. That's number three solution. Yeah, Steve, I actually thought of everything. You won't, you don't even know how much I was thinking of all of this. I'm trying, it's really difficult because some people are on the market for 7 years and we don't see a lot of progress, to be honest. And it's difficult to just step in, out of nowhere. And you have to already compete with existing players. And I just had to think of everything. So basically, if you guys want to see something cool, or maybe not so cool, I considered so many different designs because originally I was trying to go with the threadless sort of threadless design, which was not very smart. But I learned fast, so which is a good idea. That was like very first prototype of heat break, and you see there is no threads. So my idea was actually to actually get maybe two parts and just squeeze them together. I was trying to work out how to actually easily swap the nozzle, like pull it out, pull it in really quickly, and I'm still on that route. Actually, I'm still trying to figure out, and I will eventually. So this was the first one of the first prototypes. It was actually I started with 3 prototypes together, and then it was one more with 3D passion on it, also chrome plated, but then we had some issues here. Oh yeah, I was trying to to study how this is gonna work out. So basically, you just insert it here, and then you tighten it with 2 more screws over here. It's the same way as you would tighten this thing over here. Oh, by the way, while we are on this is 598 diameter, and my manufacturer didn't like this requirements, obviously, but this is gonna fit so tight inside of your basically inside of here. I kind of feel just a little bit of resistance even without screws. So basically this is gonna help you so much. It's gonna help you with the thermal transfer between this part and this. And I'm kind of I was already explaining to people, so even if you have like 0.1 millimeter difference between this part and the whole, metal is not elastic. You can't just wrap it around like a lot of people see like on this aluminum. Yes, it's soft, but you really can't wrap it around. It's just gonna bend in one spot, and you're just gonna kind of push it right towards the wall. But if the curvature is different, then you're not gonna have good connection. Like period, you're not gonna have it there. So for me, it's super important to have like as tight tolerance over here as possible. And I'm telling you, there is less than 0.01 millimeter over here. I can feel the metal, which is big deal, which is big deal for performance. And maybe that's why also I don't experience. A lot of people ask me, why Vlad, why you don't? Where is our sock? Where is the sock for this? We want to wear socks. And I said, like, why do you want to wear socks on this? And because it's gonna once you turn on the fan, it's just gonna get cold immediately. And I said, like, I never experienced this. I do experience 2 degree drop for 3 seconds. If this is why you want to soak, I mean, I'm not making a soak basically. So that was the why I'm mentioning the tight tolerance of the heater plus the power on the heater, because I'm having heaters up to 100 watts. It's a lot of heating power. So basically they can catch up really quick. Yeah, socks, sandals, hats, not gonna include with Nova, basically. Replying to Juan, tell me, is it Juan or Juan? I'm sorry, I always mess it up. Replying to that question about retraction, I didn't have any retraction issues. I usually, basically, there is almost no oozing, and I'm usually printing with 0.5 nozzle. And even when I print TPU, for example, like flexible plastic, I don't have any oozing to be, to need to use like significant retraction. My retraction normally is 0.8 millimeters. Sometimes it's 1 millimeter, but I never go more than that just because I don't need it. And I did test it with larger retraction. It was like 2-3 millimeter retraction. it was printing just fine as well. So I cannot comment on any clogs because I was just not able to clog it basically. If you guys get it and clog it somehow, let me know. And that's what I said on my Kickstarter campaign, because I was trying to clog it so badly, and the only way I was able to clog it is just to leave it for half an hour without fan on the heatsink, and that clogs it. But when it clogs, you just pull it here, make it a little bit hot over here. If it's PLA, make it like 100 degrees, and then you pull everything. And by the way, guys, give me a minute. I want to show you how the cold pull looks like. This is very self-explanatory. I want to see if I have it. Give me 1 second. I'll be right back. Yeah, unfortunately, I'm not able to find any like cold pull samples, but basically the sample looks so precise. Like it would just cold pull and like ridiculous, it's like just a strong line, and then it would have like 60-degree angle over here. And if you had any filament outside on the bottom, it would also have like a little pimple in the end. So basically in the perfect shape of your insides of your hot end. So that's what I call a perfect cold pull. And that's why maybe it won't even clog, because it's just so straight and nice. So yeah, that's my cold pull. So Joanne I plan on doing something similar to the Prusa multi-material, where I'm going to retract filament completely out of the hot end and swap filaments. It should be fine, as as far as like filament as a liquid state, it would retract with like completely flat end. Like I retracted it many times hot. I just don't normally do it because I don't have multi-material. But yeah, it should be just fine. It's a lot of stuff, guys, still has to be tested. Of course, I'm not like a million people corporation. I tested everything I possibly could. I printed with PIC. I printed with all flexibles, Ninja Flex, TPU. I actually printed with TPU at 200 millimeters a second, which was absolutely ridiculous. Actually, I don't even know why it printed like that and why it doesn't print with normal hot ends, but it actually does. I was able to reach 200 millimeters a second, which was crazy. I actually tried from 50. And then I was doing increments of like 10 and 10 and 10. I was doing 60, 70, 80, and I see it doesn't even care. So then I just pushed it to 150, and it would still not care. And then at 200, I would get a slight under extrusion on flexibles, which is really great. I mean, if you guys can quadruple your speed of flexible printing flexibles, it's really nice. I just use a normal MK10 extruder, guys, nothing fancy. And that was very important for my testing because I don't want to use like, bond tag. I have a bond tag on my machine, on my main big machine, and I have not posted any testing results from that machine just because I thought it's kind of not fair, if I use bond tag and that, like, you guys, not everybody has that expensive extruder. So basically, I was just using basic, MK10, which is like this, and you have like a little frame over here and just passing. Nothing special, nothing fancy. Yeah, every time L3D, every time I'm actually looking at people printing, I always want to comment on Instagram, like, why so slow? Why so slow? I just feel it's really slow. Speaking of these moon steppers, I'm actually thinking of sourcing these steppers. I can actually get them at a really good price. I spoke to a factory, and not in the United States. In the United States, for some reason, they sell it like $50. And I was thinking, like, why it's so expensive? I mean, like, is it China? If you guys don't know China, let me explain. China, they don't have habit of overpricing stuff. Even if it's good stuff, they still usually it's reasonably priced. Just because competition in the country is so fierce, they don't have a like custom of overpricing stuff, like ridiculously overpricing. Like if your hot end costs $6 and you sell it for $80, I think that's ridiculous overpricing. It's like, how can you even like, or at least make it better, Tiny bench, yeah, of course, I have it here. One second. The question is how tiny you want to go. Is this tiny enough? Okay, no. I think that's not tiny enough. Is this tiny enough? I think this is not tiny enough, actually. Let me go a little bit tinier for you. Is this tiny enough? This is the close-up. I don't know, how is the focus? Is it good? And I could actually go smaller. How about this? You guys want to see tiny? That's tiny. This is the most tiny bench. Look at this bench. If my focus ever. Okay, now it's good. So this is the bench. It's not perfect because it's like so tiny, but it's pretty good. Smaller than this, Steve? I don't have smaller than this. This is pretty darn small already. Or maybe I actually do. Let me see. Maybe I think I even have smaller bench. Let me see. I have a Metro Hikers spaceman somewhere. This is printed in the vase mode. This is 0 infill, 1 layer, 0.25 nozzle, and this is the vase mode. I think my son actually got the smallest benchy. I could ask him, but I don't. Yeah, I think this is not the smallest. I think I printed even smaller. But yeah, this is a spaceman that I printed. This is just normal PLA. I don't know, the lighting good for you guys? I think this is amazing quality, to be honest. And it's like really tiny, and considering this is actually vase mode, it's really nice. You guys want to see prints? I mean, I have a lot of prints. Like this was printed with matte white PLA. Top is messed up just because I messed up. It was my printer test machine maximum because hot end was hanging out. So basically, the bed actually hit the floor, and literally like 1 millimeter was off. But yeah, this is the quality for the vase, another vase, and I have these things. I have a lot of those. This is just straight printing, but this was printed at 200 millimeters a second with a lot of cooling. It's the same thing here. It was a speed printing, but I cannot comment. I don't remember what speed that was. And what else do I have here? I have this line. This was one of my favorite filaments. I cannot get it anymore. It's so not shiny PLA, sort of matte PLA. And have lots of stuff. Not everything is interesting though. Okay, this is the worst quality print I did on this hot end. And partially it's because of the plastic. I think plastic was not very good. Somebody kept asking me to print something like this at 300 millimeters a second. Obviously, you cannot, guys. I mean, I didn't. Somebody also told me it was false advertising. I wasn't. I kind of assuming, common sense. You can't break laws of physics. You cannot print this at 300 millimeter. I was printing it rather slow, probably normal speed, but I don't like the quality, and I would never ever print this thing on FDM machine, to be honest, because it's a torture of FDM machine. But because people were asking, here's this lamp. I mean, this is good, but I don't think layers came out any good at all. You have to play with settings, and I don't normally do this kind of stuff. But I think it's decent. I think every machine would print it like this at least. What else? You guys want to see something? Well, I was printing like that's a large bench. I was printing with a silver PLA. And is that enough, or you guys want to see more prints? I have a lot of prints here. Also, not every plastic is the same. I had some bad plastics over here as well. This I was printing. This is the sort of wiggly ways. I have this model posted on 3D Passion. Also, I want to mention layer adhesion, right? That's how I pronounce it, right? So it doesn't break. It's PLA. So I don't know about you guys, but for example, with that Flash Forge, I had MK10 extruder, and there was quite a bit of problems with layer adhesion, even on PLA. With Nova, you don't have it. You see, I mean, it's PLA, and I kind of squeezing it a lot, and it won't even break. Oh, I mean, I can actually not this one. I can sacrifice something. I can sacrifice these ways, but first I want to show you the surface. This is, I believe it was like 0.2 layers. So basically, I think this is perfect. I mean, you cannot probably go better with FDM at all. And especially, I was printing with my lousy Flash Forge machine. So basically, yeah, look. So this is it actually broke, but it broke on the side. So layer adhesion is pretty good. My poor vase. Okay, guys, ask me questions. I see 10 people watching me. Ask me something. I think I covered all of it. I mean, I can show you where the heatsink started. It was actually, you see, this thing was even smaller because I was trying to push it as much as possible. This is the first prototype of Nova hot end, the first heatsink. And what I was going to do, I was going to do a brass insert over here, which I'm not going to do any longer. Oh, and if you give me a second, I'm actually gonna show you. I'm gonna show you the Bowden fitting that is going to be used on Nova. 1 second. Okay, this is what I'm not going to use. I'm not going to use this type of thingy because it's just not good. Basically, I kind of saw A3D using it, and I thought, yeah, maybe it's a way to go. You know, it looks slick. You know, it's pretty nice looking. You can put it right inside of it, right? But the problem with this thing is actually it has a lot of play, and it's just, I don't agree that's a good solution at all. Because I mean, of course, you can plug it in, and then it's still gonna play. So you can make up some sort of C bracket to fix it. But why would you want to bother with all that so much? Why don't you just get, you know, a good solution, right? It just that works. Solution that works. That's my point. And if it actually fails, you're gonna have a lot of problem because you're gonna have to unplug it somehow and take it out. So basically, my solution is simple as that. You just use this. I actually tested 7 different models of this kind of fittings, and I stopped on this model. This model is it offers absolutely zero play. There is zero, like it's just zero play on it. Like it's so tight over here, you guys not gonna need to use any brackets, no nothing. Then you just click this thing over here, right? You squeeze it and you pull it. Hard to do with in the air, but yeah, you just pull it like that. So you know how this works. So this kind of fitting just insert perfectly in here, and you get your Bolden setup. And with Bolden setup also I want to mention something. Tolerances. I didn't offer any allowances here. So basically, over here is going to be pretty tight. You still can insert it. You don't need to insert it far, but it's going to be pretty tight over there. Same thing for inserted over here. It's pretty tight, but I think it's just amazing. I mean, you don't have to. It doesn't have to play. See, it's absolutely tight over there. So this is 4.0. This is my special tubes. I'm gonna sell them on my shop as well. These tubes are Japanese Teflon. It offers 20% more. 20% more. Oh, my English is failing right now. 20% more. Less friction. Let's say less friction. That's a solution for me. 20% less friction. So basically, this is a much higher quality Teflon material. The actual raw material is double price of what everybody else is selling. And this material actually has FDA food application certificate. So if you guys print something for food, you might want to use this kind of tubes. And it's not only that, they actually extra small as well. So they're 1.9 millimeters inside. So all goodies are combined in this kind of tubing. One tubing for all. So yeah, and basically the tube, once you insert it, it has to go a little bit. So I want to show you with this thing inserted. I think my tolerance here is so tight, so I might even have to pick certain parts to match perfectly. Some of them may not even fit. I haven't tested it yet, but it's just so tight. So basically, as you see inside, it's not all the way, but there is a hole all the way. So basically, my idea, if you are on Bolden setup, you just push it all the way, and it's gonna meet the heat break right there. So if you don't push it, if you don't want to push it all the way, I'm going to offer a little insert, which is going to the insert. Actually, I'm gonna just do it STL probably because it's just easier. So you guys can insert it here to replace Bolden sort of setup with a flat insert for the plastic, because over here you see there is it's M6 hole. So if you want to insert filament in it, it might, if it's flexible filament, it might actually wobble. So basically, what I'm gonna do, I'm gonna offer you STL, so you can actually insert a little plastic part on it, and it's gonna solve it. That's how I use it now. It's absolutely zero problem. I will provide STLs. Yes, I already answered it in here. I will provide STLs for mouse modeling. I will also model mounts myself for popular models like Creality printers, Prusa printers. I'm going to model it. I actually modeled one already for A3 model, for NET A3 model, and some of them are still pending. I still have to model it, but before you guys receive it, as I promised, I will do my best to model every single popular mount. And as I mentioned before, speaking of these motors, I might actually do a combined order. If I get like 100 people buying this, I could actually make this motor happen for like $28 probably, maybe 25 even, plus shipping. But it's still really good deal. For like, they sell it for $50 over here. I don't know why. I mean, they are more expensive, but not that much more expensive. Kevin is asking, with all the tight tolerance, any distortion from heat cycling? If you can clarify what you actually mean, because I don't have, like, I didn't have any distortion, but obviously you had, so maybe you can explain what that even is, because I didn't see any kind of distortion during any printing. I could put, Steve, I could put moons on my website, that's fine. I could also do it on Amazon. The problem is I have to buy, and the minimum quantity to buy these motors are 500 motors. If I want to get a price from the factory from China directly, I have to buy 500 motors. And obviously I can just, they're not cheap. It's like probably gonna cost me like 7, 8, maybe more thousands of dollars, which I don't want to invest right now. I can't, because I invested here and there, and I put a lot of money in Nova as well. And in case you guys think I made a lot of money on Kickstarter, I didn't. It was basically to pay for, to start the project. And that's what it did. And I'm actually very appreciative for that. But it wasn't really for profit, especially at this volume. Yeah, let me answer. I would really love if you guys ask me something, because I don't have a lot of content. Basically, I'm just talking what comes to my mind here. And for those people who actually just came here at the Nozzles, and every nozzle you will get every nozzle polished. They all polished, like mirror polished, like ridiculously polished, stupidly polished, or whatever you want to call it. So let's see. After use, Kevin, I'm afraid I don't understand you. I'm so sorry. After use, removing parts, can you feel the difference? Use remove. I don't know. If you guys can clarify, I can answer that. Yes, Steve, I might put moves, as I said, on my website, but I have to. There is minimum order on the factory. And Steve, again, about the survey, I cannot do it on a Kickstarter just because the price you guys all paid for shipping already paid, especially international. The United States is not so bad, but international bakers paid $18 for the shipping. And if I just put this in a box, it's gonna increase the shipping price so much, because $18 was relying on, because it's so light. It's just like quarter pound, maybe less, for the whole box. If I put this, it's immediately going to be over a pound. So maybe I'm not even able to ship it like that. I cannot just throw it in the box as you intended it, I believe. Len is asking, I'm a beginner to 3D printing, so I choose the recommended items you suggest. However, how soon would I need to upgrade? Is it wiser to plan for later and intermediate? Len, I'm not sure which items you choose. If you chose beginner package, so it means you chose NTC sensor, and you chose 60-watt heater, and basically probably maybe a nozzle tool, which I also recommend. It's such a lifesaver. And when will you need to upgrade? Probably never. I mean, you don't really need to upgrade. It's gonna work just fine. It's gonna print everything just fine. It's like on your computer, you have like GTX 780, for example, video card, if you guys are into computers, and then next time 980 comes out, but you can play most of the games on 780 as well. So upgrades are a very tricky subject, and I'm not here to milk anyone, so I'm not going to tell you, oh, buy this, like the biggest upgrade here, blah blah blah. No, if you guys feel like buying it, feel like having fun, I love upgrades, and I always max up all my systems. My computer is like micro ATX, and it's having ridiculous processor inside. and I had to do a custom water cooling inside of it and just 3D print some, even 3D model some stuff to actually fit it inside. But yeah, it's actual upgrades is very, it's a questionable subject. If you feel you're gonna benefit from it somehow, if you're like at that level, you might want to upgrade. But if you buy beginner pack Nova, it's gonna work for you forever, until it's like wears out, which I'm not sure what exactly is gonna wear out in these metal things apart from nozzles, because also heaters they last pretty long time. I hope this answered to you. If you have additional questions, just shoot it to me. L3D, how much was your Bowden tube? I probably want a bit of it for the gap between hot end and extruder. A bit of the Bowden tube I'm gonna throw for you all guys for free. You don't need to buy it. And I'm not a corporation. I'm not gonna tell you buy 10 centimeters of Bowden tube from me. I have plenty of that. I'm just gonna throw it for everyone. And I have a little space over here, so I might just get a holder for that little piece of tube. Idea was to do that, right? But the problem is here, even if you insert Bowden tube, I'm sorry, I'm out of picture, right? Even if you insert Bowden tube, you still have like sort of outside area, which I don't think is perfect. So I think it's better to actually 3D print something with like a precision nozzle, maybe just a tiny part to insert there. Because unfortunately, I should have actually thought of it. Maybe I'm gonna machine something from metal, because I don't like for example, what the 3D had. They had separate heat sinks. This is a Bowden heat sink. This is a direct heat sink. I don't want to do that. I want to do it. I want to do one heat sink, and then maybe like have it adapt to like different situations. So basically, I might actually machine a little part for you guys. And yeah, I'm sorry, I kind of overlooked it, but I'm gonna include the tube for sure. I'm reading Kevin comment, trying to wrap my head around it. After some hours of printing, okay, disassembly of sliding parts harder due to surface finish changes from heating and cooling cycles. Well, that's more about the plastic, but I never had this kind of problem at all. I mean, if I'm gonna start printing ABS with open printer, of course, it's just gonna distort all the time, but it's nothing to do with the hot end. It's about your cooling, about your chamber temperature, about different stuff, but it's not about hot end. The hot end job is to melt plastic and to extrude it, and to do it as stable as possible and as fast as possible as well. That's where my goals for when I was designing Nova. Speaking of like distortion, it's not actually distortion. I would say it's like deformation. It's a better word, I think, because yeah, the part could totally deform, especially ABS. But I didn't have any kind of this kind of issues with Nova at all. And I did print ABS, of course. And ABS is kind of tricky, and I think it's gonna disappear from the market in a couple of years probably. I'm not a huge fan. That's why I decided to instead use carbon fiber PLA and just anneal it. So finish is still pretty awesome. It doesn't have any warping, no nothing. And I just boiled it. And by the way, if you guys anneal PLA or any other plastic, what I did, I just boiled it in the water for like 5 minutes, and it does the job just fine. You don't have to do like sophisticated setup. I did try, by the way, oven as well, but the result is exactly the same. So you don't have to waste electricity or waste a lot of time. Just put everything in the oven for half an hour, then cool it down. I don't know. I mean, this is working in boiling water just fine. Yes, Steve, I might do a survey on Instagram if people want to do it. Just maybe do some kind of pre-orders, but I have to finish this project first because it's really important for me. I hate being late like that, and I'm trying to push it as much as possible. Oh yeah, L3D, good point about 24 volt, because I'm trying to go entirely 24 volt, but to be honest, I might actually start producing heaters for 12 volt, because that was also overlooked, and I think it was a mistake. I think I have to offer 12 volt heaters, at least for 60 watt. For people who still have 12 volt printers, I mean, they're not gonna, rebuild the whole machine just, for the sake of installing my fancy hot end on it, right? So basically, yeah, I'm gonna offer you guys 12 volt heaters really soon. It's gonna be after Kickstarter, but I will make it for sure. Next batch is gonna come with 12 volt. It's not gonna be 100 watt, not gonna be 80 watt. It's gonna be just 60, but you will have an option for that. And for those who are using, by the way, guys, for those who decide to not buy it from me, I strongly recommend, for sensor, I strongly recommend to buy it from me, because this sensor hole is ridiculous. I mean, the fit on this hole is ridiculous, and the screw that tightens it over here, it's also pretty ridiculous. So, and for ridiculous stuff, you hate. I mean, I'm the only person who is selling ridiculous stuff. It's not for my profit. I just recommend for your convenience, at least buy a sensor from me. This whole sensor has like really tight tolerance, and it has to be custom fitted. And I fit it manually I'm gonna fit it manually with every single part, so to make sure it works. And for the heater, actually, if you guys want to buy third-party heater for 12 volt, you're going to need to have at least 5.95 5.95 diameter for this heater. They all say just basically 6 millimeter, right, diameter, but it wasn't precise enough for me. So it has to be 5.95, from 5.95 to 6. If you get it lower, then you're gonna have pretty bad, not pretty bad, I mean, not worse than everybody else, but you're gonna have bad connection over here. It might not tighten might not tighten well as well. So basically, I recommend to watch the tolerance over here. Michael, I think it's Mikhail. Is PT100 wiring heat protected? Since it's supposed to be, yes, of course. I mean, I'm Vlad, I heat protect my wiring. Look at me, especially for Mikhail. Look at this. This is fiber isolation, not super tight. I'm gonna change it next time, but it's fiber. I don't use. If you guys buying something for high temperature setup, of course, it's gonna be. Actually, not only PT100 are protected like this. My NTC sensors are also protected like this, because why not? I don't like silicone to be used on such applications, to be honest. Especially socks. I don't know. I mean, silicone socks put right here. Just not a fan of it. Mikhail is asking about motors. Yes, I could add, but as I said, minimum order quantity is 500 motors to get a good price. I could get like 100 if I speak to them for a little bit more, but still, it's a big starting volume, and then I have to produce. For those of you who are not familiar with like retailing, I have to actually produce a retail box. I can't just ship it in the plastic bag like some people ship their products. I just can't do it. So basically, I have to produce a retail box for it, and the retail box is 500 units minimum as well. So I have to at least get some starting orders for it, to start. And this is for future. I'm not like I'm first gonna finish this, and this motor I'm only considering actually to actually build a whole extruder assembly for Nova and sell it as extruder. And by the way, Nova has so little back pressure on inside of this heating chamber. For example, if you guys, depending on your printers, of course, you can print 300 if you have a large machine. If you have a small machine, you cannot print 300 on a small machine, probably, right? Just because, I mean, unless it's a vase, you might be able to print it really fast. But it's going to be a limitation. If you have a small machine and if you're not planning to push the speed so ridiculously, you will take advantage of cooler printing, cooler temperature printing, and you will take advantage also of low back pressure. Low back pressure will allow you to use smaller stepper, much lighter stepper, and it's going to help you improve print quality, because low back pressure, that's basically why you want to use larger steppers is because of back pressure here, or maybe plastic is not melting fast enough. Nova is like, it's a monster who's going to consume all your plastic pretty fast. It's copper, you know, you guys shouldn't even worry about melting it. So basically my idea is to actually use smaller, and I'm going to show you the stepper type. Give me 1 second. This is a stepper type I was using on my, I mean, have you guys ever tried to use such stepper on your extruder? Probably not gonna work. I was printing with it for 5 days actually, and it was working just fine. It would skip very occasionally if I go too fast, but up to 80 millimeters a second, that was totally fine. And I was actually pretty surprised that I could, you know, I could really use this stepper on extruder. And speaking of these steppers, they are a little bit more powerful for the same weight. They have power to weight ratio is a little bit higher, not much, probably 15%, but it actually helps. So my idea, I might be able to offer this kind of thing even without gears. I mean, you don't even need gears if you can print it like this. Also depends on the plastic. PLA, no problem. Maybe if you want to print something like carbon fiber PLA, a little bit thicker plastics, maybe. I haven't tested it, but what's funny, I tested, it worked, and I wanted to share it with you. Reading the chat again. Part of the hot ends, how can they distort? I don't even know. That's what yeah. Kevin, oh, okay, parts of the hot end distortion. How do you imagine aluminum distort from 300 degrees? I don't know. Or becoming stuck because of light tolerances, tightness. Yeah, I printed peak with it at 500. I mean, it was nothing. Of course, you're gonna have some sort of how it's called. The part is gonna shrink, and the second word I forgot, but whatever. It's gonna change the volume just a little bit. Yes, it's gonna happen. But up to 300, I wouldn't even worry. Up to 500, it will become more noticeable, but it's not gonna, you know, it's not gonna deform in any significant way for sure. There is copper inside. Copper melt temperature is like 900 degrees or even more. I don't remember. Excuse me if I'm wrong, but it's not even nearly 500. So nothing is gonna deform. Aluminum, this part is not even gonna get warm. Trust me. You're gonna be very surprised by how little heat is actually passing over here, just because it's actually double thinner. It's actually twice thinner than different heat breaks. Like for example, E3D V6 heat break that I'm actually selling as well. Their wall over here is double the thickness than my wall. So basically, probably that's why I don't have any problems, you know, with like tiny heatsink and also tiny fan. It's 25 millimeter fan, and this fan is only you only need to run it as like 20 to 30% of the speed, not even full speed. I mean, basically, almost. If you, I just suggest people like you may print without fan. That's fine. I don't guarantee that because who knows, you know, that's like I just don't want to guarantee without fan. But you can put a fan on it. There is like a little trench over here, so you can click it in and it holds like that. So if you print it with a fan, you can just install a fan, set it up to like completely noiseless, like 25-30% of the speed. That's how I'm printing right now, and you're never gonna hear it anyways. So basically, it's better to use a fan. Okay. Upgrading printer. Let me actually go in the order. I think I skipped someone. If I do a pre-order with prepaid, Mikhail, what happens if I don't gather the volume that I need? If I don't gather at least like, I don't know, 100 people, then I can't even serve first pre-orders. You know, like how am I supposed to deal if it doesn't, like on a Kickstarter? You know, if you don't reach your goal, then what do you do? I don't have a system that will charge people after. Kickstarter does, but I don't have that system. Hi, Alfred 3D Printer. You are late, man. You're so late. I don't know if you can catch up. I actually covered so much stuff already, and it's been hour and 20 minutes, and some guys left already, and I'm still here. I don't know if I should cover it one more time really quick and just finish it. Do you guys want, like, how many of you joined late? You can tell me. Yeah, man, but to be honest, I chose 8 p.m. California time, and this is kind of middle ground for like everybody on the planet. Most of people, you know, I tried to figure out. I mean, we all have time difference. It's probably gonna be 5 a.m. somewhere, regardless, you know, of when I'm gonna stream. But let's see. Yeah, copper melting even over 1,000 exactly. So I'm not worried. And copper is actually covered in chromium. It's even like I'm not worried about it at all. So the question from the person with some I don't know what name that is. You do not need to upgrade. No, upgrading printer from 12 to 24 volt. It's only worth it if you build this printer yourself. If you purchase the printer, there's absolutely zero reason to upgrade it to 24 volt. It's easier to actually sell the machine and buy another one, especially at this time when printers are so cheap. You actually don't, like, I don't suggest upgrading voltage, because you're gonna need to upgrade a lot of stuff. You're gonna put a lot of money in it, considerably a lot of money, not $1 million, of course, but it's not worth it. The value, you're not gonna get value out of it. It's much easier just to buy a new machine and sell this machine if you want to go 24 volt. That's my answer for that. For the video, I'm not sure how long I'm gonna keep this video over here. I might actually not keep it for long. I'm probably gonna keep it for 48 hours and then just delete it, just because I don't want to keep it for all the time. But basically, that's it, guys. If you don't have any more questions, I really appreciate you for coming, and I'll stay here for about 5 minutes more, and I will expect more questions from you if you have any, especially add-ons, because I received so many questions about add-ons on Kickstarter, and my idea was to actually cover that. So basically, here's your jewelry, male jewelry, which is gonna come. I don't know if visible or not visible. And as you can see, there is different plating inside, because these heat blocks are double plated. They're double plated. It's not just chrome, because you can't really plate it with chrome everywhere, but I still wanted chrome, so I double plated it. It's chrome nickel plating. It's nickel on the bottom, and then on the top is chrome. So here's my eye candy. I so love how these guys came out. I mean, they're absolutely beautiful. Thank you, Steve, as well. Thank you for coming, guys, and I hope I was helpful, because the most idea was like just to answer questions in very efficient time for everybody. But to be honest, you guys didn't have a lot of questions. Most of guys who came basically came for fun, as far as I understand, which I had a fun as well, and I appreciate you for coming. So for those who didn't see the set, this is the set. This is the thermal paste I'm gonna include for free. I'm gonna also include a piece of this tube for free, which is, of course, I would include piece of tube for free. It's so small, why would I charge for it? But yeah, and this is the set. That's how it looks, guys. For those who joined later, Steve had a lot of patience. I mean, Steve, you actually stayed with me from the beginning. It's been almost an hour and a half. I really appreciate it. That's a great patience, especially with my accent. I wanted to show you these guys while I'm on it. These were my actually very first blocks, and my stupid CNC, the very first vendor, actually made brass instead of copper, but it doesn't matter, they didn't work out. So the idea was, as you see, there is like a cutout in the middle, right? So the idea was to sort of tighten it like that. So you can see, like, I'm doing stupid stuff sometimes. I just want to show you, like, I am doing stupid stuff sometimes. I just learn by mistakes. So this was quite stupid as well. This even smaller cutout, really stupid. Like the biggest mistake was that I actually assumed that metal is somewhat elastic, which is like absolutely not true. It's almost zero elasticity on it. So you couldn't even like tighten it like that. So that was a like huge mistake, which I'm pretty ashamed of. But I just want to show you I did make a couple good amount of mistakes, I would say. So yeah, I guess that's it. That's it. What did I forget to show you, guys? If someone wanna buy my plastic, by the way, here's a 3D version, 3D version PLA, and I'm not gonna sell PLA anymore. So you can grab this one on Amazon if you want. Because I'm not gonna sell because of the volume. Volume is so low, and I actually was excited to launch my own PLA, but it turns out, there's like so many offers on the market and so little demand, so I didn't really go for it. And I decided I'm just gonna sell out what I have and not gonna produce unless I can produce something really special. And I was actually planning to do plastic with it. Since I'm not gonna produce it anymore, that's my prototype spool. And this was that's what I was planning to do, but since there was so little sales, I kind of backed up from the idea. So this has a look at this spool. The spool is actually reusable, and it can come. It costs the same money to produce it as a normal spool. So basically, I can ship it with spools, I can ship it without spools, and that's how it could work. And winding, of course, just like crew cement, pretty good one. And 0.02 tolerance. But it's not happening, unfortunately, not enough sales. So at least for now, I had to put it on a shelf. So yeah, guys, looks like we don't have any more questions. So I think I'm done over here. And I'm just gonna read, it was a pretty fun time. And also, the answer. Yeah, I tried to cover all questions. I think I did it pretty well. Yeah, 1.5 hours. That's a lot of time. Yeah, it wasn't stupid, no, but actually, Juan, that was actually pretty stupid to even assume it. In like any engineer would say, like, dude, what is wrong with you? Why would you even do that? So, but we all make mistakes. I think mistakes are part of the fun, part of the progress. Yes, pool was a really good idea, but couldn't really. Nova, no, it's not gonna have wooden box just because it's so much more expensive to produce, and I think it doesn't really make much sense. Wooden box was produced myself for prototype. I kind of carved it using my CNC, and yeah, wooden box, guys, it's not gonna happen. I'm sorry, just because it doesn't make much sense to waste money like that, and it's significantly more expensive. The box for Nova, I decided it's gonna be 3D printed insert like that. And it's carbon fiber PLA, and it's like really custom insert. It's gonna have everything on it, basically, and nozzles and everything. Thanks for 3D printing, I can actually custom make it like that. It's really nice, and it's gonna be a pain in the butt, to be honest, to print all of it, but I'm down for the challenge actually. And here is how every part. This is actually screwed onto the set. Like these guys are actually screwed inside. This one also. So yeah, I decided this kind of mount is going to be much better because, for example, over here I cannot pre-install heater, I cannot pre-install anything, and how will I put it anywhere else? I mean, it raises a lot of questions if I do it this way. And this way, actually, it solves all my problems with packaging. So yeah, guys, hit me up on the moons. What you guys think? The motors actually run cooler, significantly cooler. What I didn't notice any big difference despite from that, but they do run significantly cooler compared to different market motors. Okay, guys, we are out of questions. I am probably out of words already, so I really appreciate your coming. And I guess we're gonna finish right now. And I'm saying goodbye. And I'm gonna just stop it right here. Yeah, only if I knew how to stop it. Okay, end stream. That's my first time. I'm sorry. All right, guys. I'll see you around.